Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 6, Solutions of a Linear Equation. So now we're going to take linear equations, we're going to find the solutions to them. So we have 17, so this first one says exercise. Find the value of x that makes the equation true. So we have a lot of stuff going on here. So we have 17 minus 5 times the quantity, 2x minus 9, equals a negative quantity, negative 6x plus 10 plus 4. That looks overwhelming at first, but just like anything else, you take it one step at a time. Okay, if you're going to read a book, you got to start at page 1. So here we go, page 1. The first thing I like to do is get rid of the parentheses, in other words, distribute. So this is a negative 5, so distribute to there. So that 17 is not going to change. A negative times a positive is negative. 5 times 2 is 10x. A negative times a negative is positive. 5 times 9, 45. Equals. A negative times a negative is positive, 6x. A negative, so it's distributing here. A negative times a negative, or positive, is negative, and a negative 1 times 10 is 10. And then that is not distributed over to the 4 because 4 is not in the parentheses, so plus 4 is just tagging along. Okay, so there we go. Step 1, we got rid of the parentheses. All right, so next thing we're going to do is combine like terms. So on the left side, I have a 17, and I have a positive 45. On the right side, I have a negative 10 and a positive 4. I'm going to combine those like terms. So I'm going to get 17 plus 45 is 62. So I'm going to keep this in standard form. So I'm going to write negative 10x first, and then 17 plus 45 is 62. Equals 6x, negative 10 plus 4 is negative 6. So just in those first two steps, we've really narrowed it down a lot. And here we go. Now, let's talk about moving x's around. The next step, what we want to do is get all of our x's on one side of the equal sign. So I have negative 10x over here, and I have a positive 6x over here. I want to either move the 6x over here or the negative 10x over here. Both will work, but I want to avoid negatives because now I'm going to do this, but I'm going to erase it. So if I did negative 6x from both sides, and I subtracted, I would get negative 16x plus 62 equals negative 6. All this negative stuff going on, we're going to end up having to multiply by negative 1 because we can't have an answer as negative x. So I like to avoid the negatives, so I'm not going to do that. Instead, I'm going to move the negative over to the other side by adding 10x to both sides. So instead of moving the 6 to the left, I'm moving the 10 to the right. So negative 10x plus 10x is 0, plus 62 is 62, equals 6x plus 10x is 16x. Bring down the minus 6. Okay, so I'm trying to get this x by itself, and keep in mind we are doing SAD map when we're crossing equal signs. And an equal sign, in order to move something across an equal sign, we have to do the inverse operations. So if I look here, I have multiplication and subtraction. Multiplication and subtraction. We do the subtraction first. The inverse of subtraction is addition. So now I'm going to add 6 to both sides. This will give me 62 plus 6, which is 68, equals 16x. It's negative 6 plus 6, 0. This is multiplication. The inverse of multiplication is division. So to cross the equal sign with that 16, I need to divide by 16. These 16s cancel, and I get x. 68 divided by 16 reduces to 17 over 4, or 4 1/4. Okay? and we found the value of x, making that equation true. Now we should always check that in our original solution, or in our original equation, I mean. So if I check that, I'll check the first one, but you should check every time. I'm not going to take the time in the video to check every single one of these, but I will check this one. And I'm going to do 2. Now that I see an x here, so instead of x, I'm going to put the answer 17 over 4. Okay, and then continue on. Minus 9, parentheses, equals a negative 6x, which is 17 over 4, plus 10, close the parentheses, plus 4. Okay, so PEMDAS says, now we're not doing SADMEP here because we're not crossing the equal sign. We're cleaning up one side, and we're not moving anything around anymore because we don't have variables. Now we're doing PEMDAS. So if I do PEMDAS, everything's staying on one side of the equal sign. Parentheses first. Well, here's my parentheses here, so I have to do in here first. And from inside the parentheses, I have multiplication and subtraction. So I'm going to multiply first and then subtract. So I'm going to get 17 minus 5. This 2 will make that 4 or 2. So I get 17 over 2 minus 9. But 9 would be 18 over 2. Okay? And I'm just going to finish one side first. So I'm going to have 17 minus 5, parentheses. 17 halves minus 18 halves is negative 1 half. And then I get 17, and now I have to multiply before I subtract. Multiply before I subtract. So 17 minus negative times negative is positive, so it's going to be plus 5 halves. Well, 17 is 34 halves plus 5 halves, and that would be 39 over 2. Now I check the other side, and I get a negative, because that's outside the parentheses. And inside the parentheses, I'm going to multiply first. So I have negative 6 times 17 over 4, so I'll put this over 1. And the 4 will become a 2, the 6 will become a 3, so I get a 2 in the denominator, 1 times 2, and 17 times 3 is 51. Plus 10. I actually need another parentheses here. That parentheses was just for the fraction, so I guess I don't need that many parentheses. It'd be 5 halves. Now let me see, what did I erase? Let's do this. It's going to be 51 halves. So I only want one parentheses. 51 over 2 plus 10, which is 20 over 2, plus 4. So that's going to equal a negative 51 plus 20 is 71 over 2, plus 4, which is 8 over 2. Okay. And when I subtract 71 halves from 8 halves, I get negative... something's not looking right. 63 halves. These should be the same. They didn't come out the same. Okay, I found my mistake, and it is right here. Negative. I forgot my negative here. So that's negative 51 plus halves plus 20 halves, which is not negative 71 halves. Negative 51 plus 21 is negative 31 halves. And it's a negative 31. So this double negative becomes a positive, and I'm going to end up with 31 halves plus 8 halves, which is 39 halves. Okay, I apologize for that sign, but there it is. 39 halves equals 39 halves. Okay, hopefully you've tried this now. Here's number 2. Here's the solution to 2. First thing I'm going to do is distribute and get rid of my parentheses. A negative times a positive is a negative x. A negative times a negative is a positive 7 plus 5 thirds equals 2 times x is 2x. 2 times 9 is a positive 18. So step 1, I got rid of the parentheses. All right, so now I'm going to get all of my x's on one side. If I subtract 2, bring it over here, it'll be negative, so I'm going to add x to both sides on this one. Negative x plus x is 0, so I get 7 plus 5 over 3 equals 3x plus 18. Now I have a denominator of 3 here, so I need to add these two together, so I'm going to change 7 to 21 over 3, because 21 divided by 3 is 7, so 21 thirds is 7. So 21 thirds plus 5 thirds is 26 over 3 equals 3x plus. Now I want to make 18 in thirds, so I'm going to multiply it by 3. 8 times 3 is 24. Carry the 2, 54 thirds. 18 is 54 thirds. I'm going to subtract 54 over 3 from both sides. And when I do that, these cancel, and I get 3x. Equal sign comes straight down, and 26 minus 54 is 28, negative, over 3. I have 3 over here, so I've got to get rid of it by multiplying by a third. Multiply both sides by 1/3. These cancel, and I get x. Actually, let me do that again. I put x on this side so I don't switch sides on you and confuse you. And 3 times 3, so it's going to be negative 28 over 9. Okay, here's number 3. If you haven't done so yet, pause the video, or try it, unpause the video, and check your answer. So here we go. Assuming you've started or done this, here we go. 4/9 plus 4. First thing I'm going to do is distribute. So I'm going to bring down this 4/9 plus 4 times x is 4x. Positive times a negative is negative. 4 times 1, 4, equals 28 over 9. Distribute this negative. 1 times x is negative x. Negative times a negative is positive 7x plus 1. I'm now going to combine like terms. I have a 4/9. I have a negative 4. I have on this side, I'll change colors. I have a 28 over 9, and I have a 1, but I also have an x and another x there. Okay, so looking at all of this, the only thing that doesn't have a match on one side is 4x, so I'm going to write that first. So 4x was all by itself, nothing to add. I need to convert this negative 4 to something over 9, so now it's going to be, let me just rewrite this as 4/9 minus 36/9, which is negative 4, equals, and then I'm going to combine these two. 7x minus x is 6x, and 28/9 plus 1, which is 9/9. So 1 is 9 over 9, which is 1. 28 over 9 came here. Now I'm going to group those and combine them. 4 minus 36 is negative 32 over 9 equals 6x. 28 plus 9 is 37 over 9. Okay. Now I want to move my x's all on one side. If I move the 6 over here, I'll end up with negative 2x. I don't want negative variables, so I'm going to subtract 4x from both sides. These will cancel. I get negative 32/9 equals 2x. 6x minus 4x is 2x, plus 37 over 9. To get this over here, I'm going to subtract 37 over 9, subtract 37 over 9, and I'm going to be left with 2x on the right. Negative 32 minus 37 is negative 69 over 9. To get rid of this 2, I'm going to divide it by 2. That's the same as multiplying by a half. multiply by a half. That will leave me with x and negative 69 over 18. One last step, if my fraction reduces, I will reduce. So it's going to become 69 is a factor of 3, so is 18. I'll divide it by 3. 3 goes into 6 twice. 3 goes into 9 3 times. 3 goes into 18 6 times. So x equals negative 23 over 6. Okay, here we go. Number 4. Again, we're going to begin by distributing. Let me just erase this out of the way so we're not distracted. Okay, so we're going to distribute. 5 times 3x, 15x. 5 times 4, positive 20. Minus 2x was not in the parentheses, just bring it down. Equals, 7x is not in the parentheses, minus, and then we're going to, actually it's going to be negative 3 times a negative 2, which is a positive 6x, and a negative 3 times 11 is a negative 33. So step 1, get rid of the parentheses. Step 2, combine like terms. I have a 15x, and I have a negative 2x. I have a 7x, and I have a 6x. So 15x minus 2x is 13x plus 20 equals 7x plus 6x is 13x minus 33. Okay. Now I'm going to subtract 13x from both sides. And something interesting is going to happen here. Okay, so when I do that, 13x minus 13x is 0, and plus 20 is 20. 13x minus 13x is 0, minus 33 is negative 33. We have an equation that came out to be 20 equals negative 33, and everybody knows that they are not equal. So therefore, in this case, there is no solution. Okay, number 5. Step 1, get rid of those parentheses by doing the distributive property. 7x is not in parentheses. Negative times a positive is negative. Negative times a positive is negative. Minus 8 is not in parentheses. Equals 1/2 times 8x is 4x. 1/2 times 20 is 10. These are no longer in parentheses, so I don't have to carry any further. Just bring down minus 7x plus 5. Combine like terms. Here's a 7x and a negative 3x. Here's a negative 5 and a negative 8. Here's a 4x, negative 7x, and 10 and 5. There's all my like terms. So I'm going to begin by combining the x's over here. 7x minus 3x is 4x. Negative 5 minus 18 is negative 13. Equals 4x minus 7x is negative 3x. 10 plus 5 is 15. So that cleans up really nicely in 2 steps. So now I have an x here and an x over here, and now I've got to move it over here because I don't want to move it over here because it'll be negative. So I'm going to add. I'm going to add 3x to both sides. 4x plus 3x is 7x. Minus 13 equals, these cancel, leaving 15. I now want to get rid of this 13, get it away from x. We're isolating the variable. Plus 13 plus 13. When I do that, I get 7x equals 15 plus 13 is 28. Divide by 7, divide by 7, cancel, x equals 4. Okay, number 6 says write at least 3 equations that have no solution. So what they're talking about is, if I go back to problem number 4, there was no solution here. Why? Because we got the same value coefficient in front of our x with different y's. So that's all we need to do to come up with something that has no solution. Okay, an x with the same coefficient and constants that are different. So there's infinitely many. I could say 2x minus 7 equals 2x plus 5. There'd be no solution, because no number doubled minus 7 would be that same number doubled plus 5. I could say 3x plus 4 equals 3x minus 4. That would give me no solution. And on and on and on. Okay, third one, they said 3, I'll do 3. 2x plus 3x, which is 5x, minus 7 plus 4. And what I'm going to do is just make something up here, and I'm going to rearrange this stuff. So I could say 2x plus 4 plus 3x minus 7. And now I see that there's a factor here. I could factor out a 2 and say x plus 2 plus 3x minus 7. That was neat. So I just made this up. But this is a total of 5x. So now let's set that equal to 5x. And this adds up to negative 3, so make it something else. 4. So if I set all this equal to this, there will be no solution, because I get 5x minus 7 equals 5x plus 4. That one was a little bit more advanced, but you get the gist, I hope. Okay, that is the end of lesson 6. Review the lesson summary and go do your problem set.